Hello there guys, how you all are doing? I hope you all will be doing fine. Welcome back to Rejoin Tech. We are again back with a new video, but wait, Happy New Year before that. I welcome you all to this new year, that is 2024. I pray for all of you to be happy, healthy and achieve all of your goals, whatever you have noted it down. So now let's continue to our video. This time we have a new entry in Leetcode playlist. We will be finding out whether an array which is given to us is sorted or not.
Sorted.
We are making this video, it is a quick video. Not sure will it be quick or not, but I'll try my best to explain you completely. So this video is important because later all the array videos will have some kind of sorting, because you have a complete module on sort which includes searching as well, because binary search and all depends on array to be sorted. So we need to sort this topic completely and then move on further. So let's quickly begin this video. So first of all, let's understand what is a sorted array. And if you haven't watched my previous video about arrays and simple operations, you can see the link in the I button. So what is the sorted array? So anything whatever follows an ascending or a descending order can be said as a sorted stuff. So here this array, this is like 2, 3, 4. These all follow an ascending order. So 2 is the smallest, then comes 3, then comes 4. So this array will be called as the sorted array. Now moving forward, we have this 13, 15 and 2. So this neither follows a descending order nor follows an ascending order, because 13 is smaller than 15, which in turn is greater than the number 2. So this won't be called as an sorted array. Now the third array which we have is 10, 10 and 10. So this technically not follows ascending as well as descending, but even though we can consider this as sorted because they all are same elements, this will also be a sorted array when all the elements are same and other elements follow the same order. So we can consider all the same elements as one entity and then we will see the next element. So this is completely sorted array. Now lastly we have 30, 10 and 5. Think for a second and then answer whether it is a sorted array or not.
Think.
So yeah, this is a sorted array. Why? Because this follows a descending order. 30 is greater than 10, which in turn is greater than 5. So this was about what is sorted array. Now moving forward, how to find whether an array is sorted or not. So as I said you previously that we have two parameters, whether it should be ascending or it should be descending order. So this is how we find out whether an array is sorted or not. So let's try this out on this array. So 2 is smaller than 3, which in turn is smaller than 5, which is greater than 1. So here this stuff fails. So this is not a sorted array. Shit! Now taking another example which has 2, 3, 5 and 15. So 2 is smaller than 3, which in turn is smaller than 5, which is again smaller than 15. So this is indeed a sorted array. So moving forward to our question. Our question is, we are given some array which consists of random integers. We need to find out whether the particular array is sorted or not, and accordingly we need to give the output as a Boolean value. Cool. So this is what we are given, an array which is our input. So lastly, the program expects us to provide a Boolean output. If it is a sorted array, provide something like true, else you can provide something like false. So now let's solve this question using brute force. So considering an array that is 2, 3, 4, 10 and say 25, how we will approach this problem? So as always, we will have two for loops, the one outer for loop and the second inner for loop. So this will be j equals to 1. It will start from the 0th index and j will start from the first index. So what will happen is that for every I, it will go to all the j and check whether j is greater than I or not. So in our question, we are considering only the ascending scenario. So for array being sorted, we need to only have ascending order. Moreover, this is also sorted, but this is sorted in descending order and we are not considering that. let's do a proper dry run of this solution.
It's a dry run.
So what will happen for I equals to 2? First of all, it will go on 3. It will check whether 3 is greater than 2 or not. It is greater. So it will move on to 4. It will check whether 4 is greater than 2 or not. So it is greater. It will move on to 10. And it will check whether it is greater than 2 or not. It will be greater and it will move on. So now let's change this to, say, for example, 1. Now the loop will come into the last j iteration and it will check whether 1 is greater than 2 or not. It is not greater, so it will come out of the loop and will get false as our output. So this was our brute force dry run, and this is really simple. Just give 10 minutes to understand and you will learn it.
10 minutes.
So let's jump to our pseudocode now. We'll write it as for int I equals to 0, I less than arr dot length and I plus plus. This is our outer for loop. Inside we will have inner for loop, that is int j equals to 1 while j less than arr dot length again j plus plus. Now if arr of j is less than arr of I, return false, or at end of this stuff will return true. So now how this will work? This will check for the scenario when arr of j, that is the inner for loop, will be less than the outer for loop. So here our outer for loop was 2 and our inner for loop was 1 in the last iteration. So it will check whether j is smaller than the outer for loop, that is I. So here this condition is true, so we'll directly return false and will come out of the loop. So this will give us the answer as false, which is true. So this is how we do the brute force approach. Now let's quickly code our brute force solution. So we are on our nvim. Let's go to our folder. Let's create the file.
The creator
Is array sorted .java. Let's open it. The file is created. Let's name the package as arrays. Why the name of package is arrays? Because it lies inside that directory. Now we'll add the snippet for class and again for main. Now let's create an empty array that will be arr let's put some random integers. Let's create a function that will return us a boolean value, that is res is sorted, which will take input as the arr. Now let's define the function. Public static boolean then is sorted. Let's take the parameter int arr. Now mostly it will cry because we are not returning a boolean here. Let's return true for now. Yes, so this is our boilerplate code which is ready. Now let's make the code working. Add the outer for loop, which will be for int I equals to 0 then we'll have an inner for loop which will be let's beautify the code little bit. so that it looks good. So let's write the inner logic. That will be simple. If ARR of I is any time greater than ARR of j, that is the value that comes after it, we are just gonna return a value that is false. So our code is complete. Let's do a quick run. Okay, so obviously we haven't added any println, so it won't show anything. Let's make it as sorted and let's print the rest there. So let's do a dry run now, and it shows it is sorted. Now let's add a false case. Let's add one here and do a dry run, and it's false. So code works fine. Now just for a little suggestion, if you want to write code little bit more beautifully, you can remove these braces. Why? Because Java gives you this feature to remove braces if there is only one line inside the brackets block. So for example, this for loop has only one statement, that is the if statement, and again the if statement has only one statement, that is return statement. Same for the outer for loop, which has only one loop inside it. So that's why we can remove the bracket and code will work in the same way. Now let's see our efficient approach, and trust me, this is really simple. So we have an array, say 2, 4, 10 and 18, and the idea here is really simple, that we are following just a simple psychological concept. So if we are traversing from left to right, and always remember this is efficient. Last one was brute force, so it was big O of n square, that is worst time complexity was big O of n square. So we need to make it somewhat equal to big O of n this time. So what will happen, say for example, when array is going on at any particular time, say we are considering these two elements, the only thing we need to consider now is that A must always be less than B. So what I am telling is this simple concept. So when we are going from 2 to 4, we just need to see whether this is true or not. So if this is true, we will move on for 4 to 10. Whether this is true, we'll move on to 10 to 18. Whether this is true. So our array is sorted. Now the simple concept which we applied here was that if an element at any particular time of traversal, the next element is greater than this one, then the array is sorted. Why? Because we are doing this from starting, right? Say for example, we started the traversal at say index second. We haven't checked the previous indices, right? So this we cannot confirm array is sorted or not. But when we are traversing from the 0th index, so we can easily say in this array that if 10 is greater than 8, that means it is greater than all of them. Why? Because 8 in turn was greater than 4, 4 in turn was greater than 2, and due to these conditions being true, we reached till this index, right? If it was false at any of these particular time, we would have written false. So this is our simple but very interesting logic in this problem solving. So now what we will do is that we'll just write pseudocode, and this one, to be really true, will be just 2 lines of code.
There's 2 lines. What do 2 lines mean?
So what we'll do is that we'll have for loop for int I equals to 0, I less than arr dot length, and this time we'll do -1, I plus plus. Why we did -1, you'll just know it. So if arr of I is greater than arr of I plus 1, return false, else return true. So this is what our really small pseudocode is doing. It is checking for all elements one by one in pairs of 2. So it is checking this one first, then this one, then this one, then this one. So if this is true, it moves on to this one, which is true, then moves to this one, which is true, then moves to this one, which is again true. Say if it was false, it was not 8, it was say 3. So the condition is false, we will directly return false here. So let's code the efficient solution, and as you have already learned that it is very easy, so let's first of all return a true value here so that the compiler stops crying.
Don't cry.
Now we'll write our logic, that is one for loop which runs from int I equals to 0. There should be ample amount of spaces, I less than arr dot length, and lastly I plus plus. And we'll have one if condition that if arr of I plus 1 is any time smaller than arr of I, we will return false. So our code is done. Let's beautify it a little bit. And yes, let's do a quick dry run. It should come as false, correct. And let's solve for the happy case, that is like when the code should show true.
Error, error, error.
So the error which happened was index out of bound exception for arrays. So this error means that you are accessing an index that is not present. So this happens, in this case it will happen when I is, say for example 5, which is the last index, and this bit of our code, that is array I plus 1, is trying to access the element which is even next to the last element, which is null. So that's why we got a array index out of bound exception. So now let's rerun it and it will be true now. So our code works.
Finally.
So this is it for this video, guys. I hope you completely understood the sorting concepts and all, and we did one more mistake, that is a typo. It should be sorted and not sort something more. So I hope you enjoyed this video.
Enjoy!
For more such contents, please follow Rejoin Tech. It will help you grow and we'll learn together.